Hello everyone, my name's Garrett Wendell, and today I'm going to be talking about my heat transfer experimental design, and this is going to be focused on the emissivity of a gray body. Alright, so just a little recap on emissivity. So what is it? Emissivity is basically just a measure of the efficiency in which a surface emits thermal energy. And so for this experiment, the process that I'm going to be using is going to determine emissivity by using light bulbs, a heat flux sensor, a thermocouple sensor, and a surface of interest. And for this experiment, that surface is going to be a lampshade. So before we begin our experiment, let's take a look at the equation that's going to be used. The general equation used for emissivity in our experiment will be the radiative heat flux, and this is also going to be assuming that the surface is a gray body, where we can also assume the absorptivity is equal to the emissivity to obtain the simplified equation below, where Q of the surface is equal to the heat flux on the surface from the source. Emissivity, we have sigma, which is equal to the Stefan-Boltzmann constant, and then we have our temperature of our surface and temperature of the surrounding. So I'll briefly go over the experimental design. This experiment for emissivity will consist of gathering heat flux data onto the surface of the lampshade using 3 different light bulbs, and all with different energy consumptions. First, we have the incandescent light bulb, which has the highest energy consumption. Next, we have the compact fluorescent light bulb, and the least energy consumption of the light bulbs is the LED. And later on, a table representing the different values of energy and heat flux will be shown. Running the experiment to collect heat flux data is fairly straightforward. However, you will need to prepare some materials in advance, such as a lamp, light bulbs, surface of choice. I use a lampshade for simplicity and to maintain the same distance for each light bulb. You also need a heat flux sensor as well as a thermocouple sensor. It is important to make sure that the temperature of both sensors are at steady state before collecting data. So once the sensors were in the correct placements and the system is at steady state, the data collection through FluxTech was started and the light was switched on. I then let the data collect for roughly 10 minutes, and after this was done, I repeated the process for the other light bulbs. After collecting the heat flux data for each 3 light bulbs, I gathered a lot of points, probably more than what was necessary, but it's good to see a little variation in the data. So as you can see on the graph to the right, the blue lines and dots represent the fluorescent light bulb, the orange represents the incandescent light bulb, and the gray represents the LED. So as you can see, incandescent was fairly larger than the other values, although the fluorescent light bulb did have a couple peaks, just wasn't very concrete data. And then the LED was all the way at the bottom, producing hardly any heat flux. So here we have the results from the 3 different light bulbs. The first row is the energy consumption right here, showing the different energy consumption for each light bulb. As you can see, incandescent's at 100, which is a lot more than all the other ones. Next, we have the distance for each light bulb. They're all placed 0.1 meters away from the light bulb. Next, the heat flux. What I did for the heat flux was I averaged the values throughout the 10 minutes of running the data, and these are the values that I received. And after that, what I did was I gathered the temperature of the surface, being the lampshade, and what I did for that was I just gathered the largest value, and then I also measured the temperature of the surrounding or the ambient air, and for that I also gathered the largest value. And then this is just Stefan Boltzmann constant. And then using the radiative heat flux equation, I solved for emissivity, and these are the values I obtained. And as you can see, the emissivity for incandescent and fluorescent light bulbs were pretty much identical. And then the LED gave us a much smaller value. And I think the reason behind this is due to the fact that the LED emits so little radiative heat energy that it wasn't able to register too much heat flux on the sensor. Therefore, just the temperature difference wasn't great enough to provide enough emissivity on the surface. So a couple errors and recommendations for this experiment. One thing I could do differently is adjust the distance of the heat flux sensor and just gather more data for the experiment. Next, I can also measure the temperature of the light bulb and see what the results would be for that. Could also use a surface above the heat source, and this would just give me a more consistent heat flux data because heat rises, and the experiment I had it off to the side. And lastly, LED bulbs are very efficient, especially compared to the incandescent. So they don't really produce too much heat off the bulb compared to incandescent. So I could possibly use a different bulb. However, this kind of helps my experiment and just gets some outlier values. And if you do this experiment, please be careful with the incandescent bulbs. They get really hot. Thank you so much for listening to my experiment. If you do this, have fun, be safe. Also, have a wonderful summer. Thank you so much, Margarita, for the great semester. Take care.